Hey guys, this is Keith Perkins with Trained by Tex. Today's video, I've got a 2003 Chevrolet Trailblazer with a 4.2 liter. The vehicle came into the shop with the symptoms of all the dash lights were on, the power windows and the power locks, the air conditioning, and a few other functions did not work. The customer did provide us with enough information that we could tell that the factory radio had been removed, a aftermarket radio had been installed, then the symptoms were immediately present at the first cycle of the key. So the aftermarket radio was removed and the OE radio was reinstalled, in which case the symptoms were still there. So the customer removed the factory radio himself and then brought the vehicle to us. Now, unfortunately, the shop environment was extremely loud that day, so I will have to just dub over the audio, but I will do my best to provide you a play-by-play with some of the same things I was walking myself through at the time and speaking to the camera. All right, guys. Uh, we'll start off with right after the scan, where I had realized that I had no communication was my primary problem, and we're going to kind of attack that. Now, remember, this vehicle is a 2003 Trailblazer, so it is a single-wire Class 2 GM network, which means that it just uses a 7-volt bias on the network provided by the PCM and the BCM. So one of those two modules has to be on the network in order for it to have that bias. All right, as you can see, the MaxiSys defaults to the 4-wall 3-wire sensor being shown with dashes through it, just indicating that I had no communication with any modules on the network. So after that, I went ahead and pulled down the trim panel below your knees there on the driver's side. I'm going to boot up my one-channel oscilloscope. This is from AES Wave. It's called the U-scope. It's a very effective tool when you're trying to quickly acquire some signals, and when you're doing something that you only need one channel, it's the perfect tool. Now I'm going to try to use I believe 50 milliseconds per division was my time base, and then my voltage scale was 2 volts per division, considering this should just be a 7-volt signal I'm going to acquire. So you're going to take your ground lead and try to get a good clean ground spot. I'm going to use the hinge here inside the door. And then the other end, I'm just going to use a regular probe, I hate to say poking probe, because we're not going to try to be spreading any terminals or anything with this. But if we disconnect this connector here, and this is about the same location on most GM trucks and vans of this era, you can see the disconnector's got quite a few wires. Each one of those wires is the single communication wire for each individual module on the network. So if you pull that plastic connector off, there's going to be a metal comb inside of there, and sometimes that comb comes out with the plastic connector. So what I'm doing is touching this comb, and it actually connects to the entire network, and since they're all shorted together, I should acquire all the signals on the one. Now you can see I indicated the vehicle's running and I've got no activity on the network. This confirms that I don't have a scan tool problem, that I in fact have no activity. Also indicate that it's at 0 point, so it's most likely being pulled to ground. Now what I'm going to do is I'm going to take that small comb out of that connector. Now what that does is disconnects every individual module from the network, because they are just spliced together at that point. Now without pulling the comb and doing this, you could depin the connector and pull each module out to perform this next function I'm going to do. This tool is also sold by AES Wave. I believe that Scott Schotten from the Drivability guys designed this tool, and really it's just all these connectors that are spliced together, and then on the other end is a 4mm banana, so you can attach it to a scope or a multimeter or whatever other measurement tool you'd like to use. Now what I'm going to do is take each one of these pins and start adding it into the pins where the comb used to be. So essentially I'm going to be adding each module back to the network one at a time while monitoring the network. So the first wire I added was the purple wire. That goes straight to the DLC. And then once I add the first module back onto the network there, you can see that I am getting some 7-volt square waves again. They look like lines, but it's just because I'm zoomed so far out. But at 50 milliseconds per division, that's the kind of activity we'd see on just one module. Now what I'm going to do is start adding modules back on by adding more of those connectors back to the corresponding pins within the white connector that I pulled from the trim panel there. Now as I do that, you're going to notice that I get more and more network activity, and that's because I'm adding more modules to the network. So each one of them has their own amount of information they're trying to send across the network. Now by doing this, I can identify when I add a certain module back in that it brings the network down. This would indicate that most likely that module is the problem, or the wiring to that module is the problem. So that's really what I'm watching out for, that as I add them back in, I continue to see activity on the network and that its integrity is still good. So you can see here, as I've added most of the modules back on, I have quite a bit of activity on the network compared to just the one module before. Now when I add the next module on, we can see the network gets pulled down significantly below the 7 volts, but it's not quite what I had before. So there's definitely some anomalies going on here. This is my first indication that the problem isn't a wiring short, and if it is, it's very intermittent. You notice I pull that module back off the network and the network seems to come back alive. So I'm going to skip that module and add the rest of them back on to ensure that there's no other modules that are contributing to my problem. And you can see once I get those connectors in that the network integrity is still good. So all I've omitted is just the one connector, which is a gray wire to that connector in pin position K, because they are lettered, not numbered. Just keep in mind that if they seem to be off color, someone may have disconnected those in the past, so you don't want to really trust their pin position or color. Especially with the gray wire, because there happens to be 2 in this particular connector. So now what I'm going to do is run a full system scan again, this time with that module disconnected from the network, and see if I can get communication back with the rest of the modules. This serves 2 purposes: to ensure that the module does communicate now, and if I notice any particular module that I know this vehicle has that doesn't show up on the scan, that's probably going to be the first place I'm going to look for which module that is contributing to the problem. Now I viewed through it and you can see the powertrain, the BCM, the SRS, the HVAC, liftgate module, all the modules were there that I was expecting to see, and there are a lot of other modules that each different chassis may kind of have back and forth. So I wasn't positive which module was missing off the network. So I grabbed a diagram. I'll superimpose it on the page here so we can follow along. What I did was I outlined the purple wire, that's from the DLC to the network connector, or the comb, and then the comb is circled there in red. That's where we're going to be looking. So on the comb there's a gray wire in position K, which is exactly with what I had, and that seems to be labeled as the auxiliary HVAC control module. Not the primary on the front, but the auxiliary. This is an LT trim vehicle, so it happens to have rear AC that has its own control module and control head. So I did notice that there was the second gray wire, which is in position G, I believe. So what I was doing here was ensuring that the one gray wire I had in K was in fact in the same position as what was in the label, or as it was labeled. And I'm inspecting to see if I actually have communication with the instrument panel cluster, because that's the other gray wire. And I did have communication with the instrument panel cluster, so I'm fairly confident at this point that the auxiliary HVAC module was our one in question. So if we go back to the back of the vehicle, I've got the HVAC module pulled out. I'm actually tapped into the communication wire to that module, and I have it connected back on the network up at the front. So I didn't show that part, but all of the connectors, I just stuck the comb back inside the connector, so it's just as it was before. And again, we notice that our network seems to be different than the previous 2 times. So whatever's going on is not a consistent fault or a consistent style fault. So what I'm going to do here to test this is disconnect this module. Now I remember having a problem with this. It was connected pretty tight, and my first indication was like, oh, I was worried if maybe something had melted, but regardless, I got this disconnected from here. Once I had it disconnected, I was able to see that the network did come back to life. So again, this served 2 purposes. One, to ensure that I was at the right module, which I was, and then by disconnecting it, I've ensured that the module itself is most likely the issue. If the problem had persisted after I removed the module, I could assume that some kind of wiring throughout that connector that connected to the module all the way up to the comb would be suspect. But since I have good network communication back here at this connector with the module disconnected, I'm fairly confident the module is the problem. Beyond that, this video was specifically designed to kind of display some troubleshooting options for you on single wire CAN networks, and these are pretty common throughout this era of General Motors vehicles. And this type of failure is fairly common. Not this particular module, but this failure in general. Um, Anyways, we tested power and grounds on the module, and it was bad. I had good powers and grounds, so we condemned the module for replacement. Alright, thanks for watching. Although I couldn't show every possible situation for a communication failure on a single wire network, I wanted to highlight a few tips and tricks that I use for this type of diagnostic. But I'd like to say thank you again for watching the video, and myself and everyone else at Trained by Techs would like to remind you to go out there, get some instructor-led training, and don't stop learning. It's the only way we can grow the industry.